Let's take a look at this example. This time we have limit with x approaching to infinity. In the numerator we have polynomial, and in the denominator we have also polynomial. In order to solve this problem, you're supposed to always look at the variable with the highest exponent in the denominator first. You have to divide every single term in each polynomial in the numerator and denominator by that particular variable. That's why I'm going to have limit with x approaching infinity, or x going to infinity, and simply divide every single term in the numerator by x to the third. I have 4x to the third over x to the third plus 2x over x to the third minus 3 over x to the third. Everything has to be over 3x cubed over x cubed minus x squared over x cubed plus 4 over x cubed. Next, we're supposed to reduce our fractions. Limit x is going to infinity, and I'm going to have 4x cubed divided by x cubed is 4, plus 2x over x cubed is 2 over x squared, minus 3 over x cubed over 3x cubed over x cubed is equal 3 minus x squared over x cubed is 1 over x plus 4 over x cubed. Now let's take a look at this expression. Numerator is constant. My x is going to infinity. Infinity squared is even bigger number. So this fraction is going to approach 0. Now, let's take a look at another one. My numerator is constant. Denominator is going to infinity and to the third power. This is also a very large number. That's why this expression, this term, will approach 0. Let's take a look at the next fraction. 1 divided by x. X is going to infinity, so that's why this fraction is going to also approach 0. Next, I have 4 over x cubed. Again, x goes to infinity, raised to the third power. Also, we are talking about the very large value of the denominator. That's why the fraction is going to approach 0. You can rewrite this as 4 plus 0 minus 0 over 3 minus 0 plus 0. Other words, this is nothing else, just 4 over 3. 4 over 3 is the solution to my problem. We have another example on the board. Again, we have limit which goes to infinity. In the numerator, we have polynomial, and in the denominator, we have also polynomial. We're supposed to always look at the variables in the denominator first. Always look at the variable with the highest exponent. My variable is x to the 6. You have to divide the numerator and denominator by that variable. How it's supposed to look like? I have limit x is going to infinity, and simply divide every single term from the numerator by x to the 6 So I have 5 to the third over x to the 6 minus 2x to the second over x to the 6 minus 1 over x to the 6 over 4x to the 6 over x to the 6 minus x to the third over x to the 6 plus 2 over x to the 6. Reduce the fractions. Limit x goes to infinity, and I have 5x to the third over x to the 6 is 5x to the third minus 2x squared over x to the 6 is equal 2 over x to the 4th minus 1 over x to the 6. Now, 4x to the 6 over x to the 6 is equal 4 minus x to the third over x to the 6 is 1 over x to the third plus 2 over x to the 6th. Please notice that x goes to infinity. So 5 divided by x, which goes to infinity. So this fraction will approach 0. 2 divided by x, which goes to infinity and to the 4th power, is going to also approach 0. Fraction with constant in the numerator, we have 1 over x, which x approach the infinity or goes to infinity, is going to approach 0. In the denominator I have 4. Again, I have constant divided by x, which goes to the infinity. This is going to approach 0. And again, I have constant divided by x, which x goes to infinity. The fraction is going to approach 0. That's why I'm going to have 0 in the numerator and 4 in the denominator. 0 divided by 4 is equal 0. This is the solution to my problem.